Okay, so just a quick video on series circuits. According to your reference table, taking a look here, the total current is equivalent to the current across each individual resistor or light bulb or item you have in your circuit. Voltage and resistance are the sum. What that means is the total voltage of the battery is the sum of the voltage drop across each individual light bulb or item. Resistance, your equivalent resistance of the circuit, is also equal to the sum among the resistance of each individual item. Now, we're going to test and look at current and voltage really quick. Resistance is generally something you calculate. I do have a resistance setting here in ohms, which I could plug in, but it's generally better to measure voltage in amps and calculate resistance, okay? So let's look at, I've got some batteries. Those are your potential differences or your voltage. I've got a light bulb, which is the same thing as a resistor. This is resisting the flow of electrons. Okay, so first thing, I have one battery. It is labeled 1.5 volts. So that is how much voltage that battery should have. This is my multimeter. Black goes to the negative portion. Red goes to the positive portion. Please remember the phrase, if you touch red, you're dead, or red, you're dead. It says 1.5. I'm reading 1.382. So this battery is probably at about 90%. Now, let's see what happens when I plug only one battery into a single light bulb. Now, all light bulbs are the same. They are the same voltage. They have the same wattage in terms of power. So when you see a difference in the light bulbs, it has nothing to do with the bulb itself. It is generally related to the system. Now, I was wondering why this isn't lighting up, and if you notice, I plugged it into a different battery. So, simple little error there. Just plug it in so that we actually create a circuit. In this case, the flow of electrons is traveling out of this single battery. It's traveling to this light bulb, and then back into the battery. We've connected the circuit. Now, I have three batteries here. And according to our reference table, the voltage, total voltage, should be the sum. Let's look at the total voltage here. This is what a light bulb looks like when it's running 1.38 volts. This is what a light bulb looks like when it's running the sum of those. So 1.5 times 3 should provide about 4.45 volts for the circuit. Oh, and I need to change it because I'm maxing out at 1.5 volts. If it's the sum, we would expect it to be about 4.5, so I'm going to change it to 9-volt battery. 4.4, so we're really close. We have a little bit of a voltage drop or a little bit of a lag in one of the batteries. Let's plug it in. Mentally think about what you think is going to happen. If we're pushing more electrons through faster, well, technically just pushing a stronger push, we get a much brighter light bulb. So there's my two light bulbs next to each other. One, 1.45 volts. One, about 4.5 volts. So the larger the potential difference, the greater or the brighter we would see that light bulb. If we think about it, it's essentially pushing more. Now let's look at what happens if I plug in two light bulbs. Bear with me here. I'm trying to hold the camera and use very small alligator clips with my opposite hand here. Not quite as bright. Now, for the sake of science, let's do a couple measurements, and then let's try and make this light bulb